What is an evolutional algorithm? In this video here, we're going to take a look at that. I'm going to explain what it is, but also how it relates to AI, machine learning, deep learning, like neural networks that we are training. So let's just jump straight into it. We have a blog post here. I have blog posts pretty much covering every single thing in computer vision, how to do evaluation of your computer vision models, what are the best practices, how to train a system end to end and all that. So we both have the blog post from Ultralytics, all those things on the Ultralytics YouTube channel as well, and inside the documentation. So when we're talking about evolutionary algorithms, it's just algorithms that changes over time and also automatically. So that could be like life on Earth. It has evolved like over millions and millions of years. Like everything is always changing automatically. We're not really doing anything. It just changes based on the environment. It could be survival of the fittest, like things just learn, like animals, all these things, they learn how to adapt to an environment, get better over time based on experiences and all that. Could also be correlated to, for example, reinforcement learning, where you learn based on things, you learn the environment by getting the rewards. You get negative rewards, you get positive rewards, you kind of like just adapt to an environment, and you can also map this to machine learning and AI models. When you want to create computer vision systems, AI models and so on, it's really important to know how it works under the hood, how are the models actually like learning, how are the parameters getting tuned, the data is going in. Most people out there think of it as a black box. They don't really know what's going on. We have some input that goes into some model and we get some magic output, and that's not really the case. We need to know and understand if we want to use the systems in the best possible way, that how is it actually like learning under the hood. So it's just under the umbrella of machine learning, like evolutionary algorithms that changes over time. If you take a look at the explanation here, it's basically just optimization techniques that gets used to adopt the algorithm over time. So there's genetic algorithms. So this is represented as simple code strings, like sequences of numbers or symbols. Improvement happens by mixing part of two good solutions, similar to combining like traits from parents or making small random changes to create new variations. We also have genetic programming, could be more like a tree-like structured programming, where we have like parent nodes, then we have child nodes, or you can also call them leaves, where we have multiple different steps. We can go in different directions, test out different directions, and also go back to previous paths as well. Evolution strategies, so basically just learning big or small changes, how we can update the solution over time, make it more efficient, improve the results by just doing more iterations. There's also differential evolution here, so it's just combining parts of existing solutions, connect the base of the both world, and improve them continuously. So all of these ones here, they pretty much just goes hand in hand and have one thing in common. They evolve over time. They have some optimization algorithm in some way. Could be human optimization algorithm, basically just like natural optimization algorithm. Could also be a loss function defined for a computer vision model, for example a deep learning model for a neural network. So first of all, we do some initialization. We need to do fitness evaluation, reproduction, replacement, and termination. This is pretty much how the life cycle works, but also how AI models work under the hood. So if you just take a look at it from a machine learning perspective with the AI models, we have initializations. So we have our artificial neural networks, convolutional neural networks. We have all the layers, we have all the nodes and all that connected to each other. We initialize the weights randomly. Could also be, if you use a base model, they're already trained, but they will still just be an initialization. So we start with some initial step, then we need to come up with a fitness evaluation. So this is just measure how well are we solving the problem. So that will be a loss function. So we have our output from the model. We compare that to our ground truth data set. Let's say that you have bounding boxes around a person. We want to match that with our output from the model. So this is why we need to use supervised learning. We need to have labels and a ground truth data set when we, for example, train the Ultralytics YOLO model, because we need to be able to do this fitness evaluation. How good are model performing compared to the ground truth? Then we can go in and create new solutions. We can test out different methods. Could be changing the weights here and there. Backpropagation, for example. We also need to do replacement, where we replace the previous weights or just make some small modifications here and there. That is the backpropagation. So we have our fitness evaluation. We get the loss, then we can use that loss to backpropagate throughout all the previous layers, see what changes can we make to each single parameter, so it gives a higher fitness evaluation, so we get closer to what we want to achieve at the end and solve the problem. Then we also have termination at the end, so this is basically just a loop running. We have our initialization, we have our fitness evaluation, reproduction, replacement. This is just a loop running for n number of iterations, also called epochs or steps. Then at the end we have termination, could be that we have achieved the results, could be that we have just trained for 100 epochs, we don't want to train for more. All these things here are basically just termination criteria. Could also be that our model is not improving anymore, so we do early stopping. So then we terminate, then we actually just have an algorithm, but this in itself is an evolutionary algorithm, and it can be matched to natural phenomena, AI, computer vision, and bots all the way down to how the Ultralytics YOLO models are trained. So here we can see the loop. Again, as I mentioned, we have the initialization, evaluation, termination, crossover, mutation. We can test out different paths, evaluations. So it could even be that you have multiple evaluations. You have automatic hyperparameter tuning running in the background. You run different experiments in parallel as well. All these things can be automated and would act like classify as an evolutionary algorithm. So it can be used in a ton of different applications out there, like bio-inspired algorithms used at windmill power plants. How can we optimize a problem without really trying to just come up with guesses here and there, but it learns by itself based on data. Could be optimization techniques in vehicle designs. How can we reduce the mass? Can we make some structural changes here and there? So they act like have a ton of, you can use this in simulations, you can go down different paths. You do like safety checks, you run it through different tests, stress tests and all that. When you make some minor changes, then you try to change something here, you try to change something here, and you see how it impacts the final results. All these things can be done in an evolutionary way. Scheduling hospitals here, you can see all these different real world use cases where it can act like be used, and it's already used today, but has been for a very long time. So this has a very large impact in computer vision, because all the convolutional neural networks out there, all the transformer models, everything related to AI is basically just an evolutionary model or an algorithm. We have some data set, we have our model, we try to learn our data set or at least patterns in our data set to solve real world use cases, generalize on our data set and improve our model over time automatically by basically just having this fitness evaluation. So the overall objective of all these evolutionary algorithms is basically just to improve the system performance, minimize the loss, maximize output. Could be any different fitness evaluations that you can come up with. Global search ability is very good. You can explore different paths, different solutions and so on, so you don't just get stuck at a local maximum. Robustness, you can test out all different types of cases, changing environments, flexibility, adjust in different ways to different kinds, and make sure that it can evaluate or not evaluate, but generalize to all different types of tasks and change based on the environment. There's of course some cons as well, like computational cost, parameter sensitivity, slow converges. It could take time to explore all different paths. If you want to do like 100 different training runs in parallel with different hyperparameter tuning settings and so on, it's gonna be slow. It's going to be sensitive to parameters. It's also going to be 100 times more expensive if you train 100 times more compared to just a single run. Fitness function sensitivity, make sure that you're able to come up with a good model of defining what is the optimal outcome and how can we describe that to use for our evaluational algorithm. This is very important to know. This is both very high level but also very low level. It's so important to know how it actually works. What is the things going into the algorithm, how our neural networks act like learning, because then it will be way easier to do your hyperparameter tuning, understand why is my model performing in this specific way. You will know all that if you know the fundamentals behind it. With Ultralytics, it's just a few lines of code that you need to do, and you can train a full computer vision model even from scratch. But if you really want to use it, make sure you understand what's actually like going on under the hood, because so many things when you hit train, so many things are going on under the hood, and it's just a single command at the top level. Hope you learned a ton this video here. Make sure go through it again, read the blog post, understand how these algorithms work. Hope to see you guys in one of the upcoming videos. Until then, happy learning.